Hey, Trig team. Trying to find something to do tonight. So I thought, well, do a little video. I talked about before a connection with, oops, what the heck is that? Try it again here. With sums, differences, versus components. All right, so just showing you a connection between Algebra 2 and Trig of doing it, getting the same results, but doing it two different ways. And maybe can I help explain to students that we're always doing the same, just a matter of seeing the dots, or connecting the dots. So let's throw off in terms of Algebra 2 first. Okay, so, and a little trig, obviously. So if we, let's look at the unit circle. I'm going to take some nice ones that we can use here on the unit circle. So let's say the 30 degrees, that those components would be root 3 over 2 and 1/2. So if I do a scalar, and let's say if I multiply by 2, that would mean that this would be root 3 comma 1. And if I multiply it by another 2 or whatever I want, let's say 2 root 3 comma 2, I can get any one and it would be all the same. Okay. Now the other one then, make it easy to say 60 degrees. So likewise, this component would be 1/2 and root 3 over 2. And likewise, I would say if I multiply by 2, I would have 1 comma root 3, and so on and so on. All right, so let's say that this would be angle A. So angle A is 30 degrees. Angle B is 60 degrees. And therefore, if I add angle A plus angle B is 90 degrees. Okay. Now, we know that because we are given those. But let's say, for example, also 2, before I go on, so therefore at 90 degrees, this component at 90 degrees would be 0 comma 1. Okay, or any multiple of that. So in Algebra 2 now, we would ask students to do things like this. And I'm going to take these two ones here, root 3 comma 1, and I'm going to put those as a complex numbers. So you have root 3 plus 1i. Now basically what the I does, it keeps track of which one's the y value and which one is the x value. Okay, so there's, that's for angle A. Okay, now the other one, and again, I can use any one I want, but I don't want to use fractions. That would be 1 comma root 3, and that would imply for angle B. Oops, and therefore the complex form of that would be 1 plus root 3i. So in Algebra 2, we ask students to do this. Root 3 plus I times 1 plus root 3i. And we don't give any meaning to it. We just say, these are some complex numbers and these are how you multiply it, and that's kind of where we stop. So let's go through and multiply those out, and I'm going to do it by the box method to try to cut down my errors. Root 3i, 1 root 3i, so we have root 3i, 3i, and root 3i squared, which basically is going to be negative root 3, so those cancel out, and therefore we would get 0 plus 2i. Now, that's not 0, 1, but what you have to do is convert it to a unit vector. So basically, you divide, if you come back right here, and this is 0, comma 2, you have to divide it by the unit vector, which is, or create a unit vector. So divide by the distance 2, and you have now 0, 1, which is what we had up there. So basically, when you multiply two complex numbers, you are actually adding the angles without actually knowing what the angles are. So the other way we do it in trig, we do it by sums and differences. So let's say sum, let's say sine of a plus b. What you have then is sine of a cosine b plus sine b cosine a. So if you look at the components that we just used up there, sine a would be 1/2. This is 1/2. This would be root 3 over 2. Root 3 over 2. So you have 1/4 plus, 3/4. And notice you get 4 over 4, which is 1, which is your y component. And lo and behold, what would happen if I did cosine of a plus b? I would get 0 in my x component. So therefore, I would have 0, comma 1. So here, I have to do it first for the cosine just to get my x component, and do my y component I do up here, where if I multiply the two conjugates together, I get both x and y simultaneously. All right, so now what happens if I divide? So let's say 1 plus root 3i over root 3 plus 1i. So this is my 60 degrees component. This is my 30 degree component. So therefore, basically, I'm going to subtract when I divide. So obviously 60 minus 30, I'll get 30 degrees. So therefore, my components would be root 3 comma 2 and 1/2, like so. So let's go through and just check this out. So you have root 3 minus I, root 3 minus I. So on the bottom, I'd have 3 minus I squared. On top, I have root 3 minus I plus 3I plus root 3I squared. Oh, what do we got here? All right, what did I get? I gotta double check my math here. 3. Give me that. Should be a negative. There we go. Therefore, that would give me, now with that, changes to positive, and I have now 2 root 3 plus 2i over 4. And likewise, if I break these down into two separate components, I have root 3 over 2 plus 1/2 I, or since I have root 3 over 2 comma 1/2. Well, there you go. So anyway, that would be the same thing if you want to do it individually. Go sine of a minus b, and then do cosine of a minus b. But again, this would be your y component, this would be your x component. But here, I did it both simultaneously. So anyway, I'm not sure if it helps or not, but hopefully kind of connect the two pieces between, the algebra 2 and therefore, the trig, and seeing, the connection between those two.